What's up, guys? It's Nick with Program Practical coming at you today with a video that this will be the third time I have shot. So, yeah, hopefully it'll come out soon. um, First off, I am a little sick. I got a sinus infection, so sorry for the sniffling. I was hoping to write out the time, but I really want to get a video out to you guys. Yeah, so we're just going to go ahead and jump on into this. What the video is today is we are going to be going over an interview problem that I've gotten in all but one of the interviews that I've gone on in my job search. Now, if you guys don't follow me on Twitter, an update on my job search, I've accepted a job. In fact, today is my first day at that job. But my first appointment with our IT manager isn't until 10, so I have time to kill. I'm standing in front of my computer, not sure what to do. So I was like, hey, why don't I go ahead and reshoot that video? And maybe even get it out, because I'm usually pretty quick with editing, so usually that's not a problem. So for you guys who don't know, I have actually joined Big Nerd Ranch. That's the shirt I'm wearing, except for this shirt is actually from my training I went to for advanced iOS training. But I did accept a job offer from them down in Atlanta, and I'm starting that today, and I'm super, super excited. And they asked the same interview question. In fact, they asked it over a web chat. Like, we didn't actually code it, we just talked through it, which was really weird but awesome. But yeah, everyone asked about this question, so let's go into it. What is it, and why did it take me 3 times to shoot it? Well, first off, the question is, given 2 arrays, return all the values that are found in both arrays. So find essentially what's not unique, an opposite of a unique search. There's a few different ways to solve that, and that's kind of what I want to jump into, the different ways we can go about solving that, and why it took me 3 times. So I shot it the first time, and I can't remember exactly what happened. There's some kind of mess up with the recording. I think it was like an audio issue. Anyways, I had to shoot it a second time, and then I was like, okay, cool, I have this shot, I'm ready to post this. And then I discovered I got a what do you call it? A keyboard for my iPad, and I discovered that Playgrounds is super amazing on the iPad. On desktop, Playgrounds is like this very buggy program that works half the time, doesn't work the other half of the time. And on the iPad, it's this super solid tool that not only has recording features, like a built-in record movie so you can record the screen, it has a straight-up broadcast feature built into it. And I can broadcast this straight to YouTube, so we might do that in the future. I'm still not sure exactly how audio works with it, stuff like that. That's why I'm still recording this on my laptop in terms of the webcam and the microphone in front of me. But honestly, I'm looking into seeing, like, can I plug those things into an iPad? Can I get all these things going? I doubt I can. But I was super pumped to see that you can record and broadcast live from an iPad, because I feel like the iPad Pro with the keyboard is such a good entry level way to get into programming. If you can't like afford the actual Mac computer, I don't know. It's really cool to see what they've done with Playgrounds on the iPad. I feel like it's a super awesome way to get young kids into programming, and they've made some awesome features that I didn't know even existed. So we're going to jump into that now, and we'll get the recording started. All right, so so here's our 2 arrays. Right now we're just doing strings. We're going to make this generic, though. We're going to use some of Swift's awesome abilities to make this generic. So we're going to not just do strings, but also ints, although I don't have the ints arrays in there. So we're looking for any one that's duplicate. So that would be easily like, we have Alex here, we have Emily here, and those both exist in both of these, where I think everything else is unique. And no reason to copy any of those. So let's first go off and just define our function. Now again, this is going to be a generics function. So what we're going to do is we're going to say, and that's just for extra points, right? If you want to impress the interviewer, be like, well, I would write this like a normal function, but I would want to make it generic since this is more utility kind of thing. Sorry for the voice. So we'll call this find I realized in my earlier videos I was calling this function find unique, and that's not true at all. So we'll call it find not unique. There we go. Yeah, that's some function naming right there. So yeah, so you might do this typically with a just like whoops, with like an array, and then there'll be like an array of strings, right? But we want to make this generic so that we can also throw integers in if we so please. So we'll do that. We'll say, hey, we're going to make this unique with a type. So anyone who's new to generics, this T just means that, hey, this is going to be generic. It's going to be kind of dependent on the type. This could be anything. We could call it array type thing. You know, you could do whatever you want. It's convention just to call it T because it's, you know, super small. You know, a capital T just kind of inherently know, oh, that's just some kind of generic type. So that's just kind of convention, but you don't have to call it T. You can use your own favorite letter. Maybe it's A or something. I don't know. But you can do what you want. So we're going to say this takes an array of type T. Whatever type T is, it takes an array of that. And then it's also going to take in a second array of that too, of type T. And then what's really cool, you can also see the errors there. Like, this is just an amazing tool. And then we're going to return an array of T. So we're going to return an array that is going to hold how many, or not how many, but how, you know, all the duplicates. We're going to hold those. So we're going to do that. And, you know, first thing it's going to complain about is the fact that, hey, you're not returning anything. So let's go ahead and just make something real quick that it can return. So we're going to say results of, and that's going to equal an empty array of type T. And we're going to just return results. And that should get the errors to go away. So yeah, so this is kind of shorthand declaration for an array. If you're, depending on how new you are to Swift, I'm going to kind of break this down to an easier level. Essentially, instead of doing like a typecasting to T, which then it would have to be optional unless you define it somehow, what we're saying is we're going to go ahead and define, a array. It's going to house this type T, but it's going to be empty. And that's how you do that shorthand. That way this doesn't blow up because it's not an optional. It'll just be an empty array right now, which if we do that, so we'll do a print, find not unique, array 1 and array 2. Oh, side note too, if you ever wondered how like it does those code snippets where it's like, hey, insert this part here, you can actually do that by doing a open pound or number sign, whatever you call that, hashtag, whatever. You put in anything you want, and then another, and then close it, and that is how those things exist. That is the code that generates those. So if you ever want to write that, if you're writing like some kind of a problem file, some example stuff, maybe like you're going to share something with a friend, and you want to like make some insertable areas, you can do that just with an open caret, a hashtag, whatever string or whatever you want it to say, another hashtag, and then a close caret. Anyway, let's get back to the video, right? Let's get back to the point. All right, so now we have this generic function. How are we going to solve this? So one of the easiest ways, not efficient, but the one that most people jump to, in fact, this is usually where I start my discussion because I like to explain that I know like these things in depth, so I like to discuss this. So I like to start here too. Is you're just going to go through 2 for loops, right? We're going to say, hey, all right, we're just going to do a for loop. So we're going to say for, let's just say a in array, and we'll call it item. That's no reason to shorthand this. Item in array. And then we're going to say for second item in array 2. Oops, you know what I did there? There we go. And then we'll say if item equals second item, then results dot append the item. It doesn't matter what, you could be item or second item. We know they equal, so it doesn't really matter what they do. But we have an issue now. So we cannot do a binary operator on this generic type because we don't know if this generic type has the logic to do an equal equal. So if you're wondering, like, what is that? So let's say I'm trying to think of a make a struct called dog, and we're gonna make it extend comparable. Okay, something like that. Now it's going to say it doesn't conform to comparable. So what does that mean? It means you have to have a few things like built in. Or I guess equatable is what we're kind of looking for. But essentially what it is a function called equal equal. And then you have like right hand side and left hand side. That's also left hand. This is obviously shorthand, but this is what the functions look like. So what this is saying down here is, hey, we don't know if this type T even has this function equal equal. We've not been told that it does. So that's a problem. So we have to make sure that it does that. Now, in generics with Swift, you can actually scope things, and it's an amazing power. So what we can do, is we can say we want to be able to find the unique arrays for type T. However, we only want to do that where T conforms to equatable. And you see that error goes away. Because now we're saying, listen, we don't know what type T is. It could be anything. It could be our own custom type. It could be a built-in type. It could be anything. However, we promise you, we are making a contract with you, it will inherit type equatable, which is where that equal equals comes in. So we are saying it will be equatable. So that's great. And this, let's see. And that solves the problem. However, it doesn't really solve the problem because this is horribly, horribly inefficient. This is essentially, if you're familiar with Big O notation, which is essentially how you calculate the efficiency of an algorithm, this is what we would call a big O n squared, because we are running through these loops twice. It scales at twice the size of the array being passed into it. So that's not good. And we need to get that down in a more efficient manner. So let's do that. So how can we get this more efficient? So one thing to do would be to not use this in the arrays, right? Arrays are just like these ordered lists, which are really powerful. But when we're going for efficiency, what else exists? So in computer science, there's these things called hash tables. And a hash table, I really wish I had a diagram to show you, is essentially a type of tree structure where things are organized based on their hash value. So if you're familiar with computer security at all, when you make a password on a website, they don't save your password. They save a hash value. So they run your password through a hash algorithm, and it creates a unique string. And then that string is what's actually saved, and you can't reverse that string. It's just a one-way algorithm. But then when you re-enter your password the second time, it can hash it again using the same algorithm and see, do these two match? If so, it was the correct password. So let's let them into their system. So you can hash pretty much anything, and you hash them, and now you have a very computer efficient manner of sorting things. It's not human created, it's compiler created, and we have way more efficiencies. Something like I researched some papers on it. Unfortunately, there's nothing newer than Swift 2. So, but in the NS hashable or NS set, they had the efficiency down to an big O like 1, which is like the like constant. It's the most efficient you can get. It's actually pretty insane. Um, from what I saw, sets, so the Swift version of NSSet was degraded over time. It was more of like a log in or something like that, but that was expected to be fixed in newer versions. Unfortunately, like I said, I couldn't find anything for Swift 4 to see if it had been fixed, but it's still way more efficient than a n squared. So what we're going to do is we're going to turn these hashables or into sets, which is really a set object in Swift is an abstracted version of a hash table, and that's what you should be using. If you're interested in learning more, first thing I would recommend is do a look up on binary trees. Maybe we'll do a algorithm on binary trees here in the future to learn how a binary tree works, because a hash tree works very similar to a binary tree. It's just how the values are set. So let's go ahead. I've rambled on enough. Let's get some sets in this, and let's rework this so it's less ugly. So the first thing we want to do is we want to we want to put both of our arrays into sets. So we're going to make a let set one, we'll call it equal set type T, and it's just going to take the contents of array. However, we got a small issue. So this needs to hash it. So it needs to hash the value. But again, it doesn't know, does T conform to hashable, which is another protocol, which essentially just declares a function like we saw with the equals that says, hey, if you need to hash me, this is how you're going to hash. So what we need to do is up here is we need to bring in the type hashable. Oops. So hashable, I don't know if it'll show me the help on it. Yeah, so as you can see, hashable actually comes from the equatable protocol, or it inherits the equatable protocol. So you don't need equatable. You just get rid of it, have hashable. Otherwise, you're declaring it twice, and that's kind of weird. Anyways, so we do that. So now we're telling that first off, they're equatable and they're hashable. So we can do stuff like making a set, even though we have no idea what type this is going to be. So there's our second set. Now what we can do here is to just swap this out and quite literally use it the way we did before. However, I would say this is still pretty ugly, and there's a way more efficient way we could be using sets, and that is, let me get rid of all that. And that would be going through here and saying, does set2 contains item? And let's see, there's a few different ways we can do that. We're going to just do this in an if statement, keep it simple. So if this contains item, then results dot append item. All right, so this is, and you might say, okay, but contains exist also in the array. So why don't I just use the array? And yeah, that's good, except for we still get in the same issue where the array isn't efficient. So by using contains, we're using a built-in algorithm by Swift, which is good because that means, let's say there is a performance loss right now. If they fix that down the road, we get that benefit because we're using their built-in function. But yeah, so this is already way more efficient than what we had before. Now we're somewhere between straight like big O, like just in or one, or probably still be in because we are still doing a loop through set. Now there is a second benefit to sets. So two things about sets. The reason why we don't use them everywhere, if they're so efficient, why don't we use them everywhere? Two reasons. First off, they are not ordered. So it becomes a hash table, which means they're weighted by their hash value. So you lose your order. You can't order them because it's supposed to be computer efficient, not human efficient. Secondly, there cannot be duplicates in your array. So if we were to have up here another Emily, right? If we were to have another Emily, this second Emily will just get removed. It was I already have that in my hash value. I'm not dealing with it. Um, so it will remove duplicates, which is also a fantastic way if you need to find the unique elements in an array. And this is another coding challenge, right? You need to find the uniques. One of the easiest things you can do is just inherit the or typecast it to a set and then return an array from that set. They'll be out of order, but still, you will have removed all the duplicates that easily. Now, one problem I ran into with this was in one of the interview problems, they accidentally messed up. And in just about every interview problem you see, they will tell you find the duplicates between two arrays, assuming both arrays are unique. Or assuming all the values are unique, meaning something like this would never happen because in their definition, array 1 will not have the same value twice. It is always unique. However, in the one they gave me, they didn't say that. I had to assume there could be a duplicate value. That's an edge case. And so that was a great chance to talk to the interviewer. Be like, well, so I want to put it as a set. However, the problem is there's nothing here saying that it's unique. So if we're willing to take that loss, if we're willing to say, hey, we're going to remove duplicates, which is really when it hurt, right? The purpose of this algorithm is to find duplicates between two arrays. So it really doesn't matter, but it's important to bring up that edge case because sometimes they want to hear the edge cases. So you bring that up like, well, unfortunately, because of this, like if we're cool with removing duplicates, sets are the best way to go. And I think the performance gains way over shoot any kind of penalty we may have. So that's something I really enjoy doing. It's that good back and forth talk. So yeah. So what's anything else we can do to make this better? Make this more of a fun interviewer response? Yes, there's always more fun we can have. So what is that? So we can do, we can make this functional, right? So we can use some functional we can use some functional stuff in this. It's already pretty functional in the sense of what it is. What I mean is we can use the reduce, filter, map, like those core functional programming kind of concepts. And I like that. So what we're going to do is we're going to make a sorry about that. Anyways, all right, and we're gonna make this functional. I'm not sure how that cut together. I coughed, so I had to cut some stuff out. What we'll do is, let's see. I'm trying to think of how do I want to do this. So to do this, we'll do a I think a filter is probably the easiest way to do this. Yeah, I think a filter is the best way we can do this. So filter this down where set to dot contains and oops. Let's see what this is upset about. Yeah, let me I'm trying to think of the let set results equal that. Okay, so this is upset because the anonymous closure argument is not contained in a closure. So I think what it wants is essentially this. Yep, there it is. It was mad because this was the anonymous argument. So anyone who's hasn't seen these before, what is the there's my great name. Oh, I guess you guys don't see the video. So the $0 is just an argument saying the first element being passed in. So with a lot of these, you'll see like item in this, right? So the $0 essentially says that first item. We're not going to give it a name. There's no reason for it. We can just shorthand this. There's no reason not to shorthand this. And then dot append contents of set results. Okay. Also not sure how key bindings work on this. Ooh, nice. That actually worked. What are you upset about? That's it. There's a new set of elements. Cannot return the expression of type. What's happening here? So that's still upset. Append the results. Let's see. I'm probably returning this wrong given the new results. So set so one thing we could probably do would be to define a new array. I feel like that's problematic. But no, it actually worked. Okay, never mind. Yeah, so we did that. So we just typecast that to its own array. Get that back in there. We can get rid of all of this code here. There it is. Still getting used to this keyboard. Got rid of that. Let's put that up there. There we go. So yeah. So that is a more condensed way of doing this. So as you saw, we first started with more of the, I would call it the junior approach, right? Just do an array and an array. And that's not necessarily wrong. In fact, that's still kind of what we were doing. Even here, doing a filter with contains, if we were to be using arrays, we would still be just doing an array and array. What changes here is because we're typecasting it to a set, or in other languages, hash tables. Because we are typecasting it to that, we are being more efficient in how we do those multiple arrays and arrays. We threw some generics in here, just because, again, when you're writing utility functions like this, it's great to use generics, because it didn't take much work to make this work as a generic, and because of that, we now have very reusable code through our project, and that's always a big win. And then we even threw in some functional programming because, hey, why not, right? Like, functional programming's fun. It's great to use those built-in functions, and it gets our code smaller. In fact, if you really wanted to make it smaller, you could make it smaller just by returning it up here, right? We could return the array. Not return, return the array. of this element. And get rid of that. And there we go. And just like that, that works too. So now we got it down to as small as 2 lines, right? We're simply typecasting 2 sets. And then from there, we are running a filter with the contains and returning an array. And I would say, so you got to be careful, right? You want your code to be readable. Let the compiler worry about making things optimal size-wise, right? Your compiler will make things optimal. You still need to focus on readable. So this might not be that readable to someone just jumping into it, or even to a junior who may not understand, like, what is this sign, right? You might want to check with your company to see, do you guys allow for those anonymous closure types? Because maybe they don't. Maybe they want things to be readable. They want you to actually define it. But yeah, so that is essentially how to do that sets take-home problem. There's a few different variants in there, right? You could stop way before I got to the functional programming part. Really, what a lot of companies are looking for when they're asking you to do this problem is, do you just do the arrays, or do you stop there, right? Do you try and put them in a hash table, right? Put them into sets. And then even that opens up conversations to, do you understand big O notation? At least on some degree. You don't have to be an expert. I'm not an expert on big O notation, but it's important to have a base understanding of it. So you get that base understanding, and then you can talk about why some are more efficient than others, stuff like that, and you can have some good conversations. This is really a fairly easy problem that can have a very very deep conversation behind it, and that is really what makes this such a good interview problem, why I've run into it in almost every interview I've done. So yeah, guys, thank you so much for sticking in through this. I know this video ran a bit long. Where are we at time wise? We're about 32 minutes. That's super long. I think my old ones clocked in around 20, but I really wanted to get into that functional part too. I love being clever with code to an extent, right? And what I mean by clever is just understanding when you can be functional, when you can be protocol oriented, and when to be object oriented, and being able to discuss that. Because again, this is a great problem in interviews where you can really show your technical understanding of a language, algorithms, and even just core computer science concepts. And that's why I think I see it like I said, almost every interview. There's only one that didn't do it, and that was just because they already know me really well, and they were wanting me to join their company anyways. But yeah, guys, thank you so much for watching. I have to jump on a hangout session with my IT manager to get my work computer set up, but it's been great talking to you. I'm Nick with Program Practical, and I'll catch you guys next.